Alright, this is again section 5-5. We're going to do numbers, this is for day 3 actually, numbers 15 and 16. The irrational conjugates theorem. Basically, the irrational conjugates theorem basically states if I have 3, let's use an actual pen, if I have 3 plus the square root of 3, then I also have 3 minus the square root of 3. Or as another example, if I have 2 plus the square root of, or if I have 2 minus the square root of 7, I also have 2 plus the square root of 7 as a root. So basically the idea is if you have something plus or minus a square root, it has both of them, both the plus form and the minus and its conjugate, the minus form. So what we're going to do is we're going to take the roots, multiply them out to get a polynomial in standard form. Okay? So here we go. These say write a polynomial function g of least degree. That means we don't have to play with it at all to make it, if it already comes out to be an x to the third, we don't have to play with it to make an x to the sixth or something like that. But of least degree, that has rational coefficients, basically, actually has numbers out there, nothing funky, and a leading coefficient of 1. And that just makes life nice. We're not going to fight it at all. We're just trying to get, if these are zeros, what's the polynomial that fits these zeros? So, we have a 0 at 3, and we have a 0 at 2x plus 5, 2 plus the square root of 5. So if we have the 2 plus the square root of 5, we also have 2 minus the square root of 5. Okay? And so we're going to take those roots and turn them back into factors. So, for example, you remember when we had stuff like x plus 5, you want to know what it equals, set it equal to 0 and solve, so x equals negative 5. Most of you have realized, oh, all we've got to do is flip the 5. It's the same idea, but going the backwards. If the 0 is negative 5, that means the root is x plus 5. The same is true here. So if my 0 is positive 3, my factor is minus 3. Because if I set that equal to 0, I'm going to get a positive 3. So f of x equals x minus 3. From here, now how to deal with those. We deal with them in the same fashion, but we're going to go x minus the 2 plus the square root of 5. Let's clean that up. And then we're going to do the same thing with its conjugate. X minus 2 minus the square root of 5. Okay? So just like it's x minus 3 over here, we flip the 3, it's x minus the conjugate. X minus those conjugates. Both with the positive one and the negative one. Alright? Now, the trick for this is how do I get this to where I can multiply it out? Well, here's what we're going to do. We're going to start off by reorganizing it a little bit. So I got f of x, and the entire time this x minus 3, until we multiply everything out, it's just going to hang out. So I'm going to just start off by distributing these negatives. So I've got x minus 2 minus the square root of 5. And I got x minus 2 plus the square root of 5. Alright? And then what I'm going to do is like, hey, I want to group, this is a bit of a trick, but it is a very useful one. I'm going to group these two together and treat them as one big unit. Alright? And here is why. With your difference of squares, what we have there now is a difference of squares. With the difference of squares, if I have x plus 5 and I have x minus 5, when I multiply those out, I'm going to have x squared minus 5 squared. We're going to write it as a minus 25, but essentially it's the first one squared minus the second one squared. Okay? So that's what's going to happen here. If you want me to show you that the long way, I can, but what happens is when I multiply these out, f of x equals x minus 3, it's going to be the first one squared. So we have x minus 2 squared minus the second one, the back half, squared. And the square root of 5 times the square root of 5 is simply 5. Okay? That's what happens there. And if you want to work it out real quick, I'll work it out once, real fast. Make sure everyone believes me. So real fast. And we got parentheses x minus 2 minus square root of 5 parentheses x minus 2 plus the square root of 5. So here's what I'm going to do. I'm going to start off by distributing the x minus 2, and then I'm going to distribute the 5. Well, the square root of x minus 2 times the square x minus 2 times x minus 2 is x minus 2 squared. So that's how I got that one. The second one, x minus 2 times the square root of 5 is the square root of 5 times x minus 2. Don't want to clean that out because it's going to go away in a second. The next one, x minus 5 times the square root of 2 minus the square root of 5 times x minus 2. And the last one, the square root of 5 times the square root of 5. Well, negative times a positive is negative. And a square root divided by itself cancels it out. Cancels it out. And the nice part is this is the same thing, but one's a positive, one's a negative. So those go away. That will happen every time. So we are left with x minus 2 squared minus 5. Okay? That's what we did there without writing the whole thing out. Okay? So back to this. If you want to pause and stare at that for a little while, go ahead, but I'm going to erase it right now. So I give myself some space. So here we go. From here, I got to multiply all that out. So I've got f of x equals x minus 3. This multiplies out to, if you want to write it twice, so x minus 2 times x minus 2 minus 5. So when we multiply the whole thing out, x minus 3, we get x times x is x squared, x times negative 2 is negative 2x, then distribute the negative 2. Negative 2 times x is negative 2x, negative 2 times negative 2 is positive 4, and then I get a negative 5 tacked on the end. And from here, I can clean it up. All right? So I get, again, f of x equals x minus 3. X squared, negative 2 and negative 2 make negative 4x, and 4 minus 5 make negative 1. And then last but not least, I need to multiply these out. Why I put a bracket on there instead of parentheses, I have no idea. So I'm going to go x minus 3 just to multiply this out. Negative 3 times negative 1 is 3. Negative 3 times negative 4 is 12, so plus 12x. Negative 3 times x squared is negative 3x squared. X times negative 1 is negative x. X times negative 4 is negative 4x squared. And x times x squared is x cubed. Combine those all together, we're going to get f of x equals x cubed. Negative 3 and negative 4 add up to negative 7x squared. 12 minus x is positive 11x plus 3. And that is your polynomial. This is heavy algebra, but most of it is stuff you already know how to do. You do need to this needs to get used to it. Alright? And then the step from here to here, you need to get used to it. Alright? Other than that, it's just multiplying things out, is all it is. It's just a lot to write down. Alright? Let's try the second one. So it says write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1 and zeros of negative 5, and 4 plus the square root of 2. So that means we also have 4 minus the square root of 2 to deal with. Or your rational roots theorem. Whatever, not rational roots. your conjugates theorem means if you've got one, you've got the other. So here we go. We're going to flip that sign to make it our root. So here I got f of x equals x plus 5, because when I said x plus 5 equal to 0, I get negative 5. And then we're going to do x x minus 4 plus the square root of 2. And we're going to do x minus 4 minus the square root of 2. All right. And then we're going to reorder that, undo the perfect square and all the difference of squares and all that. So here we go, f of x equals x plus 5. So I've got x minus 4 minus the square root of 2, x minus 4 plus the square root of 2. And I'm going to go in and I'm going to group these two together, because now I have a difference of squares. Alright, I got the same thing on the left, the same thing on the right, and I got a negative on one and a positive on the other. So here we go. F of x equals x plus 5. And on the left-hand side, we're going to have x minus 4 squared. And on the right side, we're going to have the square root of 2 squared, which is just 2. All right. Now I got to multiply all that out. So we get a f of x equals x plus 5. And I always tell you, whenever you have a polynomial squared, just go ahead and write it out twice. If you can get by without losing those middle terms, go right ahead. But I would rather use a few pen strokes to do it right the first time than jack it up. So that's x squared minus 4x plus 16 minus 2. Feel free to pause it if any of those numbers are messing with you at all. And then we'll combine those. F of x equals x plus 5, x squared minus 8x plus 14. Alright, let's regroup at the top and we'll multiply them out. I have x squared minus 8x plus 14 times x plus 5. So 5 times 14, 5 times 4 is 20. So 50 plus 20 is 70. That's 70. 5 times negative 8 is negative 40. 5 times x squared is 5x squared. X times 14, that's a positive 14x. X times negative 8 is negative 8x squared. And x times x squared is x cubed. Here we go. And then bring everything down. So, in this case, f of x, to get those roots, you're going to have is equal to x cubed minus 3x squared minus 26x plus 70.